uh, we will talk about the functional units of the kidneys. Functional units of the kidney are called nephrons. So nephrons are the functional units. We will talk about the nephrons, different types of nephrons, parts of a nephron, and how a nephron produces urine. Then we'll talk about the capillaries inside the kidney. Inside the kidney, there are three types of capillaries are present. So we'll see what are those three types of capillaries inside the kidneys. Okay, so we'll see that, and then we'll see the processes of formation of urine, how a nephron produces urine. Nephron is the functional unit of the kidney, right? So that means what? Each nephron should be able to produce urine. That's why it is called the functional unit of the kidney. So we'll see how a nephron produces urine. First, the parts of the urinary system. You have two kidneys, two ureters, one urinary bladder, and one urethra. So those are the parts of the urinary system. Now, two kidneys produce urine. So production of urine is the function of the kidneys. Very simple, right? Production of urine. Now, if I ask you how kidneys produce urine, by filtration. Filtration is the mechanism. Okay, so kidneys produce urine by filtration. After the urine is produced in the kidneys, the urine is transported or taken to the bladder. Who takes the urine from the kidneys to the bladder? Ureters. Those two narrow tubes, okay, transport the urine from the kidney to the bladder. Is it clear? And bladder holds the urine for few to several hours. That is the function of the bladder, holding the urine for few to several hours. You know that kidneys continuously produce urine because blood is continuously going to the kidney, right? And kidneys are continuously producing urine. If you didn't have bladder, what would have happened? The urine continuously would get out from the body. That's very uncomfortable, right? Nobody wants that urine. So bladder plays a very important role, holds the urine for few to several hours. When you desire, you can excrete the kidney out from the bladder. Now, who takes the urine out from the bladder to the outside of the body or to the atmosphere? That's the urethra, the last part of the urinary system. Now, urethra is different in male and female. Other structures are same, but urethra, that part is much shorter in female and longer in male. Functions. Kidneys remove toxic chemicals and metabolic wastes from the body. Kidneys regulate the volume of blood. How? Very simple example. If now you drink a lot of water, what your kidneys will do? Produce more urine, right? Why kidney will do that? Because when you drink a lot of water, the blood volume goes up, right? So kidney will produce more urine to bring the blood volume back to normal. Make sense? Otherwise, blood volume will increase, blood pressure will increase, right? So that's not good. So now if you don't drink water for a few days, then what kidneys will do? Produce very small amount of urine, right? Highly concentrated urine, because kidneys will try to preserve the water, retain the water, because your body needs water, right? So you see, by regulating the volume of urine or production of urine, your kidneys regulate the blood volume. Is it clear? Okay. Regulation of chemical composition. If any electrolyte or chemical is increased in your blood, then kidneys will do what? Will filter and excrete more, that chemical more. So the chemical concentration will go down. Okay. That is very simple. Regulation of pH. How kidneys regulate the pH? You know that if hydrogen ion concentration increases, then pH will be what? Decrease, right? Opposite, negative logarithm of hydrogen ion concentration. So if hydrogen ion increases, then pH decreases, right? So if hydrogen ion increases in your blood or in your body will become acidic or alkaline. Acidic. More hydrogen means less pH means more acidic. Make sense? What is the pH of your blood? Very good. To 7.45, right? That's the rate. That's the pH of blood, right? Neutral pH is what? 7.0, right? So above 7.0 is acidic or alkaline. Your blood is alkaline or acidic? Alkaline, slightly alkaline, right? So if pH goes below 7, that is what? Acidic. Make sense? So less pH means acidic, right? Towards acidic. So if hydrogen ion concentration increases, the blood will move towards acidic. Is it clear? Because pH will go down. So in that case, what kidneys should do? Excrete more hydrogen ion, right? So pH will go up to bring the pH normal. So by regulating the hydrogen ion concentration, your kidneys regulate the pH of the blood. Okay. Endocrine functions. Inside the kidneys, two important chemicals are produced. One is called renin, another is called erythropoietin. Renin helps to regulate the blood pressure. And erythropoietin, you have heard this word before. Erythro indicates erythrocytes, red blood cells, and poietin, poiesis, production. So erythropoietin stimulates the bone marrow to produce red blood cells. So these two chemicals are produced in the kidneys and perform two important functions. Renin regulates the blood pressure, erythropoietin stimulates the production of red blood cells. Activation of vitamin D. With the help of sun, your skin produces a chemical that is called cholecalciferol. You already know that. That chemical is produced in the skin. We have talked about this before many times. Cholecalciferol, which is inactive vitamin D, right? Inactive form. Then from the skin, the cholecalciferol goes to the kidneys, and inside the kidney, it is converted to calcitrol, which is the active vitamin D. Okay, so inside the kidneys, cholecalciferol is converted to calcitrol, which is the active vitamin D, and that's how your kidneys help in synthesis of vitamin D. Now the question is, from the skin, why cholecalciferol should go to the kidneys, not liver or in other pancreas or other organs? Why? Because inside the kidney, you have the chemical that will convert. That is called the converting enzyme. Okay, converting enzyme is present only inside the kidney. So inside the kidney, it will be converted to calcitrol. Other organs don't have that enzyme, so that will not be converted to active form. Okay, now we'll see the anatomy of the kidney. Kidney is a retroperitoneal organ. You already know from digestive system, this is the abdominal wall. This is the peritoneal cavity, right? And you know that most of the organs are inside the peritoneal cavity. Your liver, your spleen, your small intestine, large intestine, stomach, all those are inside the peritoneal cavity. But there are few organs, those are outside of the peritoneum. Those are called retroperitoneum. So retroperitoneal organs are kidneys. Okay. So this is the peritoneal cavity. This is the peritoneum attached to the wall, right? And kidneys are behind the peritoneum. That's why say retroperitoneum. Kidneys are located in the lumbar area. This is the lumbar area here, and right kidney is slightly lower than the left. Why is that? What do you think? Right kidney is slightly lower than the left, because you know that the right lobe of liver is much bigger than the left, right? So when the right lobe of the liver is grows, it pushes the right kidney slightly downwards because it needs some space, extra space. Okay. Renal hilum, the area in the kidney where the ureter and renal artery, renal vein, that means the renal blood vessels, ureter, lymphatic vessels, nerves pass through, either enter or gets out. That area is called the renal hilum. Okay, like hilum of the lung, you have seen in the lung, right? The bronchi and blood vessels enter. Okay, so that's the anatomy of the kidney. Now, inside the kidney, if you cut the kidney and see inside it, it has an outer part which is called the cortex, outer cortex, and inner part is called the medulla. Okay, and inside the medulla, you will see triangular, pyramid-shaped structures. Those are called renal pyramids. Triangular or pyramid-shaped structures are called renal pyramids. Okay, and in between the pyramids, the areas are called columns. So in between two pyramids, this area is called the column, renal column. Okay, so kidney has outer cortex, inner medulla. In the medulla, you have the pyramids, and in between the pyramids, the areas are called columns. Now, each pyramid and adjacent columns together form a lobule. So each pyramid and adjacent columns together form the lobule or lobe. So this is a lobe, this is another lobe, this is another lobe, this is another lobe. Okay, so pyramid and columns together form a lobe. Now the pointed end of the pyramid is facing inwards, and that pointed end of the pyramid is called papilla. So papilla is the pointed end of the pyramid which faces inwards. So that's inside the kidney. Now let's see here. You see, look at the right side picture. You see the cortex, medulla. In the medulla you have the triangular pyramids, and in between the pyramids you have the columns, and the pointed part of the pyramid which is facing inwards, that is the papilla. Okay. Now the papilla is surrounded by a cup-shaped structure. So if this is the papilla here, this is the papilla of pyramid, okay, and the papilla is surrounded by a cup-shaped or funnel-shaped structure that is called the minor calyx. So this is the minor calyx, okay, and what happens actually, you see, the urine is secreted from the pyramid, papilla of the pyramid. So urine slowly gets out from the papilla and enters into the minor calyx. It's like a cup or funnel. Okay, so urine is secreted from the papilla, enters into the minor calyx. Make sense? So here I can say this is the papilla and this is the cup. That's the minor calyx. So urine goes there. And from the minor calyx, from a number of minor calyces, urine enters into the major calyx. So if this is, let's draw this way. This is one pyramid. This is another pyramid. This is another pyramid. There are many inside the kidney. These are the papilla. So minor calyx. This is another minor calyx. This is another minor calyx. Okay. So all minor calyces drain the urine into major calyx. So this is the major calyx. So from the papilla, the urine will be given to the minor calyx, and then minor calyces will drain the urine into major calyx. Then a number of major calyces will join to form the renal pelvis. Will give the urine to renal pelvis, and from the pelvis, the ureter will take the urine out from the kidney. Now let's see here. So what happens from the papilla? Urine enters into the minor calyces. These are the minor calyces, and from minor calyces, urine will go to the major calyx. So this is the major calyx, and from major calyces, the urine will be given to the renal pelvis, which is the wide space here, and from there will enter into the ureter, and then ureter will take the urine to the bladder, right? And from the bladder through the urethra, it will get out. So that's the pathway of urine, how the urine moves. Okay. Blood supply of the kidney is very important, because I told you that inside the kidney, the harmful toxics and metabolic wastes are separated from the blood. That's the function of the kidneys, right? Filtration, separating the harmful chemicals, toxics. So blood supply of the kidney is very important. About 1/4 of your total body's blood supply or circulation enters into the kidneys. Although your kidneys are very small, like this, you know that your kidneys are like this size, 2 kidneys, but 1/4 of your total body circulation, blood flow, enters into those 2 kidneys. That means a lot of blood goes inside the kidney, right? If your cardiac output, we know that our cardiac output is about 5 liters. That means cardiac output is about 5 liter or 5,000 milliliter, and about 1/4 of that blood enters into the kidney. That means 1250 milliliter, right? 1/4 of that enters into the kidney. If your cardiac output is 4800, then 1200. So 1/4 of your total blood flow circulates inside the, or goes inside the kidneys in each minute. We'll see the circulation of blood inside the kidney. First, you know that renal arteries take the blood from abdominal aorta, right? From the abdominal aorta, renal artery arises and enter into the kidneys. Immediately after the renal artery enters into the kidneys, it divides like this into two arteries. Those are called segmental arteries. So anterior and posterior segmental arteries. So you see here, renal artery enters through the hilum of the kidney and divides into segmental arteries. And then the branches of segmental arteries enter into the columns. So from the segmental arteries, branches enter into the columns. And you know that this is a lobe, this is a lobe. So this artery is now called interlobar artery. That means in between two lobes. When it runs through the columns, in between two lobes, that is the interlobar artery. Here, interlobar. This is interlobar. Okay. Interlobar artery between the lobes. And then what happens? The interlobar artery makes 90-degree angle turn. So let me draw again. This is the kidney pyramids. Right? So from the segmental artery, interlobar, and then from the interlobar, the branches arise and they form right angle, like 90-degree angle here, and start to run along the base of the pyramid, like this. And these are now called arcuate arteries. Arcuate artery. And from the arcuate artery, several branches arise like this. And now you see all these branches are inside the cortex, because this is the cortex of the kidney. So these are called the cortical radiate arteries. Cortical radiate arteries. Okay. And then what happens? From the sides of cortical radiate arteries, small arteries arise like this. So since these are the smallest arteries, these are called arterial, afferent arterial. So these tiny arteries are afferent arterioles. Now we say arterioles because these are the smallest arteries. Okay. So you see, I'm repeating again. Renal artery enters through the hilum of the kidney, and immediately it divides into two segmental arteries. And then from segmental arteries, branches go through the columns. These are called interlobar arteries. And then the branches of interlobar forms right angle and start to run through the base of the pyramid. This is the base of the pyramid, and these are called arcuate arteries. And from arcuate you get the cortical radiate, because these arteries are now inside the cortex, cortical radiate. And from both sides of cortical radiate you get the smallest arteries, those are afferent arteries. Okay, so you see in that picture, interlobar, then arcuate, then cortical radiate, and you see those tiny branches, those are the afferent arteries. Just remember that far, then we'll talk from there again. Okay, so you see here, from the left top, aorta, renal artery, segmental artery, interlobar artery, arcuate, and cortical radiate. From cortical radiate, you get the afferent arterioles. Now what happens? The afferent arterioles, now we'll see the afferent arteriole. So this is the cortical radiate and these are afferent arteries. The end of the afferent arteriole forms capillary. We know that from the end of the arterioles, capillaries are formed, right? And the capillary from the afferent arteriole is very long. Long capillary is formed, but that long capillary forms a round ball of capillary. So this is the afferent arteriole, and from the end the capillary starts, but that capillary forms round structures. These are called glomerulus. So glomerulus are the ball of capillaries or tuft of capillary. We say tuft of capillary or ball of capillary. That's the glomerulus. Okay, these are glomeruli. Now, from the glomerulus, what happens? The arteriole that takes the blood out, that is called efferent arteriole. Exit. Okay, so this is afferent. Again, afferent arteriole takes the blood inside the glomerulus, and efferent arteriole takes the blood out from the glomerulus. Okay, and your nephron, the functional unit of the kidney, starts here. So see, it's beautifully designed. So this is the nephron. Now I'm drawing in nephron. So this is the nephron. So from each glomerulus, a nephron starts like this. Okay, and another one starts here. Another one starts here. So from each glomerulus, a nephron starts. Now, nephron is the functional unit of the kidney. That means a nephron can produce individually. A nephron can produce urine. Each nephron produces urine. So first we'll see how the filtration occurs in the kidney. You see, when the blood circulates inside the glomerulus, that ball of capillary, this is very long, right? Because it is a ball of capillary. So if you make it straight, it must be very long. It's like, your grandma or older women, you'll see they knit sweater, right? Use the ball of yarn, right? So glomerulus is like that, a ball of capillary. And if you make it straight, it will be very long, right? So now you tell me, after blood enters into the glomerulus, it will stay long time or very short? Short. Why? Because this tube is very long. If it is very long, the blood will stay long or short? Long, because it is very long. Like blood has to pass long way, right, to get out. So it will circulate like this for a long time. Make sense? That is very important, because when the blood will circulate inside the glomerulus, through the wall of the glomerulus, water and toxic chemicals, other chemicals will get out and will enter into the nephron, and that is called the filtration, glomerular filtration. That means when the blood will circulate through the glomerulus, water and other chemicals will get out, because in the wall of the glomerulus you have many holes, fenestrations. You remember fenestrated capillaries, big holes. So water and other chemicals will get out and will enter into the nephron, and that is called the glomerular filtration. After the fluid enters here, the fluid will start to pass through the nephron. Now, before I talk about the fluid movement inside the nephron, I'll see the parts of a nephron. This part of the nephron is called the renal corpuscle. Okay? Renal corpuscle. This part. And rest part of the nephron is called renal tubule, because it is like a tube, renal tubule. So a nephron has two parts. First part is called the renal corpuscle, this part, and this part, the rest whole part is called renal tubule, because it is like a tube. Now if I ask you, renal corpuscle has how many structures? You have two structures here, you see. This is what? Tuft of capillary, that is called what? Glomerulus, right? Glomerulus. So you have glomerulus here, and this part of the nephron is called glomerular capsule. So these two parts together form the corpuscle. So corpuscle consists of renal corpuscle, consists of the tuft of capillary, glomerulus, plus glomerular capsule. Now, so the corpuscle has those two structures, the glomerulus and glomerular capsule. Now you see, your glomerulus is, this is the tuft of capillary or ball of capillary, okay, and capsule is like this, covers, partially covers the glomerulus. So this is the capsule and this is the glomerulus. Those two structures together is called what? Corpuscle. Okay, so this part is the renal corpuscle. So the filtration occurs here in the corpuscle part. Is it clear? Filtration occurs in the corpuscle part, right? And then the fluid will start to move through the tubular part, tubule. Now we'll see the parts of that renal tubule. This first part you see of the tubule is convoluted, not straight. That's why this is called proximal convoluted tubule. Proximal means first part, distal means last, and why it is convoluted? Because it is not straight, convoluted, okay, spiral. So proximal convoluted tubule. And then you see this part, it looks like a loop, right? Like a loop, hairpin you used in your hair. So this is called the loop of Henle. Loop of Henle. And then this part, is the distal convoluted. Again it becomes convoluted, not straight, and this is the distal convoluted tubule, BCT. This is PCT, proximal convoluted tubule. And then distal convoluted tubule gives the fluid or urine into the last part, that is called the collecting duct. So this is called the collecting duct. What's the function of the collecting duct? Collecting, right? Duct means tube, big tube. So it collects the urine from what? From the distal convoluted tubule, right? What happens here? Each collecting duct collects urine from several nephron. That means what? You see here, another nephron starts here, right? You know that. So this is another nephron here, just like this, and distal convoluted tubule drains in this collecting duct. Another one, okay, will drain the collecting duct. So each collecting duct collects urine from several nephrons. Make sense? So it's a big tube where many nephrons drain the urine. Okay, so those are the parts of a nephron. Okay. So let's see. How many nephrons you have in each kidney? Each kidney has approximately 1 million nephron. Can you believe that, like, this much organ? Inside it you have about 1 million nephrons. Now we can just think that how small a nephron is. Very small, but tubular structure. So in two kidneys you have about 2 million nephrons, and each nephron can produce urine. How beautiful, right? Each nephron is so small, tiny, but each nephron can produce urine itself. Okay, now we have talked about the parts of a nephron. Here you see different parts. You see the glomerulus, you see the glomerular capsule. Those two together form the renal corpuscle, the top part, renal corpuscle. Then the tubule. Renal tubule has proximal convoluted tubule, loop of Henle. It should be HE, not HA. I think I wrote HA. Loop of Henle, HENLE. And then the distal convoluted tubule and the collecting duct. Okay. Now, we see what happens after the fluid enters into the nephron. Again, I'll draw the nephron, proximal convoluted tubule, then the loop of Henle, distal convoluted tubule, and the collecting duct. Okay. So, filtration. By filtration, the fluid enters into the nephron from the glomerulus, and then fluid starts to move through the tubule. When the fluid passes through the proximal convoluted tubule, 65% of everything is taken back into the body through the wall. So, through the wall of the nephron, everything will be equally taken back. That means what? Water and other chemicals you have here. Everything will be taken back into the body, and that is called reabsorption. Okay, reabsorption. So when anything is taken back into the body through the wall of the tubule, that is called what? Reabsorption. Is it clear? Anything, remember this is very important, that will remain in the tubule will not be reabsorbed, will remain in the tubule, will get out as urine. Whatever left inside the tubule, okay, it will become urine. So that is one process called reabsorption. And also what happens when the fluid passes through the tubule, in some areas some chemicals will enter into the tubule from the body. That is called secretion. So secretion is just opposite of reabsorption. Reabsorption takes out back into the body, and secretion gives into the tubule. Make sense? So opposite, just opposite. So now you tell me if you understood. If sodium is reabsorbed, that means sodium is going where? Back into the body, right? So if sodium is secreted, then what will happen? Sodium will leave the body, right? Will enter into the tubule and will get out with the urine. Is it clear? So anything that is secreted, that will leave the body, will get out. Anything that is reabsorbed will be taken back into the body. Is it clear? Okay. So now you tell me, if hydrogen ion concentration increases in your blood, in your body, it should be secreted or reabsorbed? Secreted, because it should leave the body, right? So it should be secreted. If something is lacking, for example, your body is dehydrated. Water should be reabsorbed or secreted? Reabsorbed. Makes sense? Should be taken back. So now you see, you already know 3 processes of urine formation. Here is number 1, filtration, which is also called glomerular filtration, that is number 1. Number 2 is reabsorption, also called tubular reabsorption because it occurs in the tubule. And number 3, tubular secretion. And those 3 are the processes of urine formation: filtration, reabsorption, and secretion. And you know which one is doing what. Okay, now let's go back here. I told you that when the fluid will pass through the proximal convoluted tubule, how much will be reabsorbed? 65%, right? Of everything will be reabsorbed. Now if, just think, if your filtration is 100 milliliter, so 100 milliliter fluid is here, and when it will pass through the proximal convoluted tubule, how much will be reabsorbed? 65 milliliter, right? 65% means, since this is 100, 65 milliliter will be taken back into the body. So how much will remain here? 35 milliliter. Make sense? So when the fluid will come from here to here, 65% will be taken back. Now 65% of what? I said everything equally. Okay. Now you tell me, if you take a solution, you have water and sugar in it. Okay. Sugar solution. If you take water and sugar equally out, then the concentration will change or remain same? Same. Very good. But volume will go down. Good. Now from the same solution, if you take only the water part out, the concentration will go up. Makes sense? Because sugar is now there. More sugar, right? You are taking water out. If you keep the water there, only take the sugar out, then the concentration will decrease. Is it clear? So this is very important when you will see what's going on inside that nephron. Understanding that is very important. Okay, now I said that water and everything is equally taken back, reabsorbed. That means the volume will go down to 35%, but the concentration will remain same. Is it clear? Okay, good. And now the fluid will start to move down to the descending limb of loop of Henle. This is the descending limb. This is the ascending limb. So loop of Henle has two limbs. This is the descending and this is the ascending limb. Okay, two limbs. When the fluid will go down through the descending limb of loop of Henle, here only the water will be reabsorbed. Only who? Water will be taken back into the body. Now you tell me, as the fluid goes down, water is leaving. Only water is leaving, right? So the concentration will go up or down? Up. Very good. So the concentration will move up, and when the fluid will reach here, the bottom of the loop of Henle, the concentration will be very high. Okay. So here the concentration is 100 to 300 milliosmol. That is the unit of concentration. Okay. So 100 to 300 milliosmol is here. But when the fluid reaches here, in the bottom of long loop, the concentration here is 1200 to 1400 milliosmol, much higher than here. Okay, because lot of water is leaving. Okay. Now you tell me, when the fluid is moving down, water is leaving. So the what will be the volume? Volume will decrease, right? So the amount of urine, you see, as the fluid is running through the nephron, the volume is going down, right? Now here 35% remains, and here when the fluid will go further down, lot of water is leaving, right? So the concentration is gradually going what? Down. No, concentration, no. Concentration going up, but the volume is going down. Yes, very good. Okay, now you see, when the fluid will start to move up through the ascending limb of loop of Henle, here something different happens. No water will leave, reabsorbed. What will be reabsorbed? Sodium, potassium, chlorine. Those chemicals will be reabsorbed, taken out. Okay. Now you tell me, it's like you are taking the sugar out, water is remaining, right? So you are taking the solutes out. So what will happen in concentration? Decreases, because you are now taking the like sugar out from the solution, right? Water is remaining there. So the concentration will go down. And again, when the fluid will reach here, the concentration will come back to this 100 to 300 milliosmol. Same level.
When it gets to the distal.
Yeah, when it will arrive here, the concentration again goes back down. Okay. But the volume is always going down, right? Always going down, because reabsorption is occurring everywhere, right? And then distal convoluted tubule, this part. Here, a hormone regulates the reabsorption. That hormone is called aldosterone. So, aldosterone hormone works on the distal convoluted tubule, and it does what? It reabsorbs the sodium and water. So reabsorption of sodium and water in the distal convoluted tubule is helped by a hormone that is called aldosterone. If more aldosterone is released, more reabsorption of sodium and water will occur there. Make sense? So this part is hormone control. Then the fluid will enter here in the collecting duct, right? Also, here a hormone works. That hormone is called anti-diuretic hormone or ADH. Have you heard this name? An anti-diuretic hormone or ADH comes from posterior pituitary gland. Okay, and it does what? Reabsorbs water on the collecting duct. So you see here the first part of the nephron, that means proximal convoluted tubule and loop of Henle. Is there any hormone here working? No hormone, right? No. This reabsorption will occur itself. No hormone is working there in the first part of the nephron. But in the last part of the nephron, hormones are working, right? Right. So last part of the nephron, in last part of the nephron, reabsorption is controlled by or regulated by the hormones. Which hormones? Aldosterone and ADH, right? Aldosterone works mainly on distal convoluted tubule, right? And ADH mainly works on the collecting duct. Is it clear? Right. Now let's talk a little bit about the hormone. Aldosterone is adrenal cortical hormone. Do you remember adrenal gland sitting on the kidneys, right? Yeah. On the kidney. So you must remember adrenal gland is like a crown of the kidney. It has outer part called the cortex, right? Inner part is what? So aldosterone comes from adrenal cortex. So it is adrenal cortical hormone and works on the nephron. Which part of the nephron? Distal convoluted tubule. Make sense? And it does what? Reabsorbs sodium and water. Is it clear? Reabsorbs sodium and water. Now let's talk about antidiuretic hormone, ADH. It comes from where? Which pituitary? Anterior or posterior? Posterior pituitary, right? ADH. So you see here, interestingly, ADH comes from the brain, right? Pituitary gland is in your brain and goes all the way down to the kidneys, right? And works specifically on that part of the nephron, collecting duct. And it reabsorbs what? ADH reabsorbs water in the collecting duct. Is it clear? So first part is not regulated by hormone. Is it? No. Yeah. And last part is regulated by hormones. Right? Okay, good. Now, what happens normally when the fluid or urine gets out from the collecting duct, 99% of the fluid is reabsorbed, taken back into the body. So how much is reabsorbed? 99. So if your fluid is 100 milliliter here, when the fluid will get out here, 99% is already taken back into the body. Is it clear? Reabsorbed. So how much will remain? 1 milliliter. Make sense? So that's how the urine is formed. 99% is taken back into the body and 1% becomes urine. So here will be 1 milliliter. Okay. Finally. So that's what happens in the nephron.
So what happens when you retain fluid? Is your ADH not working properly?
ADH, if ADH is released more water will be taken back, reabsorbed, right? So your body will have more water. If ADH is not released, then what will happen? Water will not. Good question. So when ADH will not be produced, in that case, what will happen? Water will not be reabsorbed, right? Right. So water will remain here. will get out.
You'll be more dehydrated.
You will be more dehydrated.
So if it's working too much, then that's when you swell.
Yes, yes, right. Is it clear?
So what happens when, because they're so small, where does the kidney stones, where do they start in this whole process?
Kidney stone is formed in the larger areas where the blood flow occurs, in the blood vessels, in those areas. For example, in the renal pelvis, minor calyx, major calyx, in those areas the kidney stones are formed.
I was just curious.
And that's why they hurt so bad, is
Yeah.
because it's a small area.
Right. But kidney stones will not be formed inside the nephron because nephrons are really small, microscopic. Yeah.
That's why I was trying to figure out.
You remember the minor calyx, major calyx, pelvis, ureter. So in those areas where the urine gets out, in those areas the stone is formed. Okay. Now, if aldosterone is released more, then the volume of urine will go down or up. Just think and tell me. Urine will decrease because sodium and water will be reabsorbed, right? So the volume of urine will go down. How about the volume of blood? Water is going back.
It'll increase.
Blood volume will increase because water is going back into the body. Eventually it will enter into the blood. If ADH is produced more, then what will happen? The urine volume will decrease. Blood volume will increase. Okay? Blood pressure will increase. More blood, more pressure, because that's the blood pressure, right? So if the volume increases, the blood pressure increases, right? Okay. Now, if I block ADH, then more output of urine, right?
Right.
More output of water.
Right.
So the blood volume will go down. And that's what we do to decrease the hypertension or blood pressure. Sometimes many patients, they take the medicine that will increase the production of urine, urinary output. We block the ADH action here. Okay. So if I can block the action of ADH on collecting that, then what will happen? Water will not be reabsorbed, right? So water will get out. Blood volume will go down, right? Blood pressure will go down. So this is one way we regulate or decrease the blood pressure in hypertension or high blood pressure. Okay.
What medication would do that?
Hydrochlorothiazide. Yeah, hydrochlorothiazide or Lasix. If someone has hypertension, take that person to urgent care. They will give the Lasix, right, to produce urine.
No, they usually give them hydrochlorothiazide first. That's what I think.
Yeah, hydrochlorothiazide. If you have hypertension, chronic hypertension, you have to take every day, right? So this is one type of medicine that will decrease the blood pressure. Another one you already know, the peripheral resistance, the wall of the artery, right? If you dilate the artery, blood pressure will go down. If you constrict the artery, blood pressure will increase, right? So that is another type of medicine given to many patients just to dilate the blood vessel. So the pressure on the wall will go down. Okay. These are the two main types of medicines are given to the hypertension patients. Okay. One acts on the nephrons or kidneys, another on the wall of the blood vessel to decrease the peripheral resistance. Okay. Okay. Types of nephrons. In our kidneys, we have two types of nephrons. 85% nephrons are short-looped nephrons. Those are called cortical nephrons. And 15% nephrons have long loop of Henle. Those are called juxtamedullary nephrons. Just know that cortical nephrons produce diluted urine, and juxtamedullary nephrons, those are long loop of Henle nephrons, they produce concentrated urine. Okay. So who produces diluted urine? Cortical nephron. And who produces the concentrated? Juxta medullary nephrons. Okay. So this is a long loop nephron, and another nephron if I draw here, this is the nephron, a short loop. Okay, so this is the short loop nephron. This is the long loop. This is the cortical nephron. This is the juxta medullary nephron. Okay. Now tell me, have you seen camels? Okay. So they should have more cortical or juxtamedullary nephrons. Juxtamedullary, because they need to produce highly concentrated urine, right? Preserve water. How about sea lion or sea beavers? Cortical, because they don't need to preserve water. They live in water, right? So they don't need to preserve water. So those are two types of nephrons and could be different in number in different creatures. Okay, here you see in the left side cortical nephron, short loop of Henle. In the right side you see the juxtamedullary nephron, long loop. Okay, long loop nephron. Now inside the kidney you have three types of capillary structures. How many? Three types of capillary structures. We'll see those. You already have seen one. Okay, so this is the capillary structure, right? Ball of capillary. That is called what? Glomerulus. So this is one capillary structure. Then this is the efferent arteriole, and this is the nephron here. This is the nephron, and this is another glomerulus, and this is another nephron, like this. Okay, long loop. Okay, two nephrons. This one is short looped, cortical. This one is long looped, juxta medullary. Okay, what happens? The efferent arteriole. You see, this is the efferent arteriole. Will go around the short loop of cortical nephron and form the capillary structure. This capillary is called peritubular capillary.
And those only move around the short?
Yes, only around the short loop, right? So that's the peritubular capillary. So you got another one. Now, this is the afferent glomerulus and efferent arteriole, and this efferent arteriole will do what? Will form a capillary structure around the long loop. That will not go like this. It will go straight like this along the loop of Henle. And two limbs are connected by capillaries like this. So it looks like this capillary structure looks like a ladder. Have you seen ladder? So two bars, right? And connected by the horizontal bars. So this capillary structure that runs along the long loop of juxtamedullary nephron, which looks like what? Ladder. This is called vasa recta. So these are three types of capillary structures inside the kidney. Glomerulus is a tuft of or ball of capillary. Peritubular capillary around the what? Around the which one? Short or short? And bhasa recta is around the long loop of Henle. Which one looks like a ladder? Bhasa recta. Okay. Which one is like a ball? Glomerulus, right? Those are the questions I'll ask you in the test. So here you see three capillary structures in the kidney.
Now say that all again that you just said.
Here,
So that one is the vastus looks like the ladder.
bhasa recta.
Yeah. And what about the second one?
Peritubular capillary.
Yeah, what did you say about that? The circular.
And glomerulus is what? Ball. Ball of urine.
That's the top.
The big ball capillary. Does that just mean black? But it will be like black. I know.
The capsule is like this, and glomerulus is like a tuft, coiled. Yeah, we will see in the lab. The lab part. Okay, now we'll see a structure that is called juxtaglomerular apparatus. JGA, juxtaglomerular apparatus. Tough names, right? So why they couldn't find the easier name? Yeah, if more you'll practice, it will get easier to you. Juxtaglomerular apparatus. How the juxtaglomerular apparatus is formed. So, again, let me draw, that will make more sense. I'm getting good in drawing.
You are?
Okay. So, this is the,
We're not.
I'm not, I know. Okay, so when we draw a nephron, every time you have seen I did draw, and in the book also you'll see like this, okay?
And what is that?
A nephron, right?
I'm just kidding.
No. Don't ask that. Okay, so this is the nephron how we draw, right? But just think that inside a kidney, how many you have? 1 million, right? Is squeezed there, right? Squeezed. They don't get that enough space. In the book, we draw that way just to show you different parts. Actually, how the nephron is inside the kidney, like this, squished. Okay, so now let's see how actually the nephron is. So this is the descending limb, this is the ascending limb. Everything is squeezed like this inside the nephron. Make sense? And now let's draw the arteriole. This is the afferent glomerulus. Different. Okay. So this is the arteriole. What happens inside the kidney? Actually, this last part of ascending limb and the first part of distal convoluted tubule. This is collecting that. So last part of ascending limb and first part of distal convoluted tubule, they come very close to the afferent arteriole. This is the afferent arteriole. And these two parts, the tubule and the afferent arteriole, together is called juxtaglomerular apparatus. So the afferent arteriole and the tubule, they come very what? Close, side by side. And that is the juxtaglomerular apparatus. Now, why this juxtaglomerular apparatus is important? Why we need to know that? Because you see here, in the wall of this afferent arteriole, only in this part, the juxtaglomerular apparatus, in the wall, you have highly specialized cells. These cells are called granular cells. In the wall of what?
The JGA.
Wall of JGA is afferent arteriole and the tubule, right? In the wall of afferent arteriole in JGA, you have highly specialized what? Cells. Those are called what?
The granular cells.
The granular cells. And the granular cells release the important chemical that is called renin. So have you heard renin? Renin? No? Yes? No? Never heard renin?
They release
Renin. Have you heard renin before?
Uh-huh.
Renin. R-E-N-I-N.
Renin. Yeah.
Renin. Oh, Renin. Renin.
Have you heard it?
Yeah.
Okay. Good. Good that you have heard it. You remember when I talked about the functions of the kidneys at the very first part of my lecture? I said the endocrine function of the kidney, it produces two chemicals. One is the renin, another is the erythropoietin. Do you remember that?
Yes, yes.
Okay. So that renin does what? What did I say? Find out and tell me. Renin does what and erythropoietin does what? Stimulates the bone marrow to produce red blood. Now I know that you have taken notes. Good. So renin regulates what? The blood pressure. Very good. So now you know from where the renin comes, right? The granular cells of the afferent arteriole of juxtaglomerular apparatus.
Renin comes from that.
The granular cells of juxtaglomerular apparatus. Now, renin does what? Regulates the blood pressure. How? Renin converts a chemical that is called angiotensinogen. Difficult name, right? Tensinogen. This chemical is present in the blood, and renin converts it to angio means what? Anybody? Close. Very close. Angio means? Cardio means what? Okay. Now you know. Cardio means what? You should know that. Angio means what? Vessels. Blood vessels. Okay. So cardio means heart. Angio means blood vessels, right? So angiotensin, if I tell you, that will work on blood vessels, right?
Right.
Tensin, increase the pressure, tension. So angiotensinogen is inactive chemical, and renin converts angiotensinogen to angiotensin 1. Angiotensin 1. And then angiotensin 1 is converted by converting enzyme to angiotensin 2. Angiotensin 2. And this is the active form, most active form. So that's how the angiotensin 2 is formed. Now, angiotensin 2 increases the blood pressure. This one, angiotensin 2 increases blood pressure.
So what does the first, not the one, but the first word, the angiotensin?
Angiotensinogen,
If that's inactive, it's just there for something else.
In the blood, yeah. It's produced in the liver and goes to the blood. But to activate that, to convert it to angiotensin 1, you need what? Renin. Okay. If angiotensin 1 is not produced, angiotensin 2 will not be produced. Make sense? And angiotensin 2 does what? Increases the blood pressure. The main action of angiotensin 2 is on the blood vessels, right? Angio means blood vessel. And it causes vasoconstriction. And you know that vasoconstriction will do what? Increase the blood pressure, right? Generalized vasoconstriction, that means what? Localized vasoconstriction is what? One area. Generalized means everywhere, throughout the body, right? So angiotensin 2 will cause the vasoconstriction everywhere in the body. That will increase the blood pressure. Make sense? So we say it causes generalized vasoconstriction. Converting enzyme. Okay. That is the main action of angiotensin 2. Angiotensin 2 stimulates the posterior pituitary to release more what? Which hormone? ADH, right? Posterior pituitary to release more ADH. Now you tell me, more ADH means what? More reabsorption, more blood, right? Increase what? Blood pressure. So this is another way angiotensin 2 will increase the blood pressure. One is generalized vasoconstriction, another is reabsorption of water in the collecting duct, right? Because more ADH will reabsorb more. You know that. Angiotensin 2 stimulates the adrenal cortex to release what? Aldosterone. You remember another hormone? I have mentioned only two hormones, right? Aldosterone reabsorbs also water and sodium, right? So that will increase the blood pressure, blood volume, blood pressure. So you see, angiotensin 2 works in different ways to do what? Increase the blood pressure. One way is vasoconstriction, another is increasing the blood volume. Make sense? Okay. Interestingly, angiotensin 2 has another way to increase the blood volume. It stimulates the thirst center in your brain. In your brain, you have what? Thirst center. So if your thirst center is stimulated, then what you will feel?
Drink.
To drink. Thirsty. You'll get thirsty, right? So you'll drink more water, fluid. So what will happen? The volume of blood pressure will go up. Okay. So angiotensin 2 works in different ways, but all those ways to do what? To increase the blood pressure, either by vasoconstriction or increasing the blood volume. Make sense? Right.
Question.
Yes.
On the test, you want every way that it increases blood pressure?
I can. Yeah.
I just.
Yeah, you understand now. So only the my part is done to make you understandable. Then rest part is yours. You have to study. Otherwise you'll forget. If you just go over, you'll remember. If you don't go over, you'll forget. Okay. Here, this is the cross section. You see the afferent arterial, glomerulus, efferent artery, and this is the tubule. And these two parts come close to each other in juxtaglomerular apparatus. And these are the granular cells. You see, granular cells. They release what? Renin. Yeah. Renin. And that. Now you tell me. Now you tell me. When the renin should be released? If the blood pressure is low or high? Low, because renin increases the blood pressure, right? So, inside the afferent arterial, this is the blood vessel. When the pressure will decrease, the renin will be secreted from the granular cells. Make sense? Okay. When the mean arterial pressure, have you heard this?
Yeah.
Yeah. Diastolic plus 1/3 of pulse pressure, right? when the mean arterial pressure goes below 80 millimeter of mercury, the granular cells will release renin. The granular cells will release what?
Right.
Renin. And renin will convert the angiotensinogen to angiotensin what?
Two.
First one, then
Then
converting
one.
enzyme will convert it to, yeah. Yeah. Okay, now, yeah, these are the three processes we have already talked about, right? Glomerular filtration, reabsorption, and secretion.
And the
Okay.
second part, we're supposed to watch the video on